So now let me share my screen. I don't one. Kiran, are you there? Hello, Kiran, are you there? Shruti? Yeah, now I'm able to share my. Okay. And I hope you remember that day we have also developed one model for the KNN, I think. Yes. So if you see in machine learning, we have lots of algorithms like SVM, support vector machines, okay, logistic regression, linear regression, decision tree, random forest, okay. So these are different types of algorithms we need to learn in very depth. Okay. Now let's see RAG and fine tuning. What is the difference between RAG and fine tuning? Now, when you say RAG, what is happening in the RAG? What is happening in the RAG? So RAG, when you say RAG, it is a retrieval augmented generation. Agree, everyone? That we have seen earlier. If you join every session, you will get an idea that what is the RAG and what is happening there. Okay. Now, let me go for concepts RAG. So RAG is nothing but it is a model which has a fixed structure. Okay, it has a fixed structures, and here you can use external documents or database to get the accuracy. Okay, so RAG here you can use external documents, external documents, or we can say data to get accuracy. But in terms of fine tuning, how you will get accuracy and what is happening in the fine tuning. So guys, fine tuning, it means suppose earlier you have trained the data on 5 million rows. Okay. If you train your data on 5 million rows, or we can say 5 million data. But later on, if you though your model is not giving you perfect answer, or we can say perfect prediction. Okay, they are giving you the wrong answer, or we can say wrong prediction. So in that scenario, what we can do? So you can again train your model, train your model with new concern data. So whatever the data you have newly available, you can just train your model on the basis of the new data. Understood now what is happening here? Okay. So you can say here, you can use external resources. Here we can use internal, because data is internal, right? It is not external. Whatever the fine tuning or whatever the data we are using, so that is the internal. Okay. Here we can use this during runtime. Means whenever you develop some RAG application, that time also, while runtime also, you can provide some external data sources to RAG while in RAG. But here you need to provide data. You need to provide this data at the time of training. Okay. You need to use, or you can say you can train your data at the time of training. Then you can fine tune the model. You cannot do like this in runtime and you can fine tune the model. No. So for the fine tuning, you need to provide the data at the time of training. Another one, RAG, it is simply, it is very easy to implement. It is something hard to implement. Why hard? Because you need to retrain. It means if you have in the data, if you have some problem in the data, if you have, is it fine now? My voice, Nirusha, is it fine? Nirusha, are you getting my voice properly right now? Everyone? Yep. Now, when you say fine tuning, so it is very easy. Sorry, fine tuning, it is something comparatively hard. Okay. It is not actual hard, but it is comparatively hard of a RAG. RAG is easy to implement. Why? Because you can just simply you can provide the external sources and you can provide the external document. Then they will LLM will read each and every document and they will give you answer. But in terms of fine tuning, it is not like that. You need to train the data, and but in your data it has some duplicacy or some uh, errors in your data. So first you need to work on it and then you need to provide it. So it is something comparatively hard. Okay. Now, cost wise, if you say cost wise, which one is better, which one is bad? So comparatively, if you say RAG is RAG, it is a low cost. Why? Because here you don't need to do anything. Everything is ready. Okay. And here you need to just use it. So it has a low cost. But here it has a very, very high cost. This is just comparatively I am studying. What is the fine tuning? What is the RAG? Okay. Now, now which is the faster and which is the slower? So you can say RAG is near, so we can say it is a slower. And here in fine tuning, this is a faster. Why it is slower? Why it is the faster? Now try to understand. When you say RAG is faster, fine tuning is, sorry, RAG is slower, fine tuning is faster, it means in the RAG, you need to provide your documents, right? When you provide the new documents, it's not easy that they will read at one shot and they will go each one by one. Okay. So they need to follow everything. What they will do, they will read your data one by one. They will convert that data into the chunks, then tokenization, then vector embedding, then blah, 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 blah. It means they need to follow each and every step. Okay. So because of that, it is a slower. Why this is faster? Because at the time of training, it means to when you provide the new data, so for the training purpose, it is a faster. At the time of training, okay, if your data is good, you don't have any problems in the data. So it is, you no need to follow any steps. You can simply provide the data and just train the model. That's it. There is no steps after providing a data. And that's why it is a fast. Understood now? Which is slower, which is faster, and what is the reason behind them? Everyone, please put up thumb if you understand. Are you understand, guys? Everyone? Thank you very much. So this is something I'm guys, please put up fill our review form. Okay. Whatever 1 hour sessions we are going to conduct for you, please, I want at least fill your attendance form and review form. I'm expecting at least these two things from you, sir, from your side. So please, I'm requesting you. The link has been shared in your the chat box. Please fill your review form and attendance form. And if you have any doubt, please put up in chat box. I will try to cover it. Okay. So this is the RAG and fine tuning. Okay. Now, there is one more thing I want to cover you in the RAG. This is in the RAG. That's chunk. This is a very important topic, and an interviewer will be asked you what are the chunking methods. So when you say chunk, what is meant by chunks? Chunks means your data is split, splitted into smaller parts. Yes? If you have multiple pages, suppose if you have 300 pages document, and if you have 300 pages document and you want to provide it into the your LLM. Now, LLM is not like that. They will read at one time and they will give you answer. So for that, you will require to make it in the chunks, right? Is it audible now? My voice is clear right now. What about now? Please put a thumb if it's good. Everyone, are you audible now? Okay, thank you. Now, when you say chunking method, so your data, what is meant by chunks? First, try to understand. Chunk is data is splitted into the smaller parts. If you have 300 pages of data, so you can make it different types of chunks. And for the chunks, there are several methods to do the chunks. Now, when you say methods, what are the methods? We will see in the details. So what are the methods? Okay. So chunking, you can say, if someone will ask you in the interview, what is the chunking? So you can say chunking is breaking your large document into the smaller pieces. Or you can say data is splitted it into the smaller parts. Okay. Now, what are the types of chunks? Okay. What are the types of chunks? Now, when you say types of chunks, okay, so first type, it is a fixed size chunks. Now, what happen in the fixed size chunks? These, whatever the text you have, you will simply chunks into the fixed size. It means, suppose you have 300 pages. I'm just taking one example, 300 pages. In this 300 pages, what you can do, you can simply convert these 300 pages into the fixed fixed size. Okay. 1 minute, guys. So in fixed size chunks, these 300 pages, you can convert it into the smaller parts with the fixed chunks. It means, suppose you will take that 1000 words in first chunk. Suppose I'm taking. This is a fixed size. You can keep any size, 1000, 2000, 300, 500. Okay. But keep in mind, while making a chunk, this you need to decide. This size, you need to decide. You cannot keep it very small or very big. Okay. Suppose if you keep it very small to 200 words. Now what happened? It might be chances to lose the context. It might be chance or there will be the probability to lose the context. Now, what should I do? So you need to decide a proper size of the chunks. So when you say 1000 words in the chunks, now what happens in that? Now, what happened? So, in first chunk, suppose you have taken 1000 words in the first chunk. In second chunk, to make the connection between this chunk and this chunk, this is your second chunk. What you need to do? You need to at least overlap. How need to make a connection? So how we can do that? Suppose I am trying one more time. Suppose this is your first chunk. So for making a connection, you need to simply overlap the second chunk. Guys, to be honest, no one will give you such types of diagrams, because this diagram is very helpful for understanding. It is very easy to understand. So when you say overlap, so what happened? These two chunks, first and second chunks, will make a connection and they will not lose the context. Not loss. It will helpful to keep understanding or proper context about the not loss of the context. So what happened with the next chunk? Again it will overlap. Third one, same thing. It means it is simply it looks like a chain, and this chain and this overlapping will help you to get the context of your previous chunk. So when user will put up the prompts to the LLM, so LLM will try to find out they will what means how it will happen. So when user will provide the prompt, that prompt will convert it into the embeddings. Yes, first it will converted it into the chunks, then tokens, then embeddings. Then on the embeddings, it will find the similarity, means which is a similar information is there. Okay, this we will take in depth in regular session. Right now I'm just explaining orally, but when we'll actually take this, I will take you practically. Everything you will get a practically. So what happen when you user will put up a prompt, it will go to the embeddings and prompts will check the similar information. So the LLM will retrieve the information. Okay, then they will reframe your answer, and then user will get the answer in proper format. So it means these fixed size chunks, you can set up the fixed number of words. That is your fixed size chunks. Okay. But every time keep in mind, when you say fixed size, so every chunk will be having same number of size every chunks. It is not like that. First time you will say 100, 1000 words. In next chunk you will say 800 words. Third chunks you will say 400 words. Not like that. So every chunk it will have a same number, equal number. Yes, understood now, everyone? Thanks, Venkata. I hope everyone is also understanding this way. Yes, are you happy with the teaching style, guys? Yeah, please put up thumb if yes. Thank you. Now there is a second type, which is paragraph based. Paragraph based. Now, when you say paragraph based, so how it is happening? So when you are providing certain documents to LLM, they will when you provide some certain documentations to LLM, they will read paragraph by paragraph. Okay, it means each paragraph is chunk in this step. Okay, it means each paragraph is chunk in this method. This is the paragraph based technique. Then third technique is semantic chunking. Semantic chunking. Now, when you say semantic chunking, it also called as a smart chunking. Interviewer will ask you, what is the semantic chunking? What is the smart chunking? Both are same. You should not be confused. Okay. So when you say semantic chunking or smart chunking, what happened? It is split based on the meaning or topic. So what happened when you provide the your document? So they will search for the topic, and every topic is a chunk here. Every topic, suppose in your document it has a multiple topics, so every topic will be the chunks for the semantic chunking. It is very smart. It will identify which topic is related to information. It will store each topic. It will convert all the topics into the chunks, and then chunks will convert it into tokens. Tokens will convert it into the embeddings, and it will store it into the vector database. Okay. Now there will be the fourth type. Fourth type, which is token based chunking. Now, when you say token based chunking, it is split on the basis of token limits. Suppose certain LLMs having a token limits. Suppose certain LLMs are having, suppose they are saying that 2000 tokens is the limit for you. So what happened here in this method, in token base, it will simply split your data. It is simply split your data on the basis of your token size, or we can say token limits. Okay. So this is also one way to convert convert your documents into the chunks. And to be honest, guys, in whatever the interviews I have conducted or I have given till now, most of the interviews having the same. This is the interviewer favorite question: what is the chunking and what are the methods of the chunking? It is not that is easy. You need to, this is just thoroughly you are taking it orally. When you go it how to make it practically, it is very interesting. And at our real sessions, this batch is going to start in the from Monday. So please complete your formalities next Monday. So you will see this concept we will take practically. It's not that right now you will see I am just explaining you, but how it will happening. I will try to show you something, but right now it's not possible because it is something time consuming. For each technique, one session will require to explain everything. Right now, I'm just giving you overview, short overview, summary information that this is happening here. But interviewer is not like that. They don't want only oral concept. They want what is actual happening, how you are making a code, how what is happening at the real time. So these all things we need to explain in very thoroughly. Okay. So in this fourth token base we have seen. Now this is the last type we will see, that is recursive chunking. Now, when you say recursive chunking, it means recursive. If you see or if you read this word, recursive means it is in iteration, iteration, iteration. It is doing iteratively or looping. iteratively. Okay. What happened in recursive chunking? Okay. Try to understand here. First, in first, it will split the data based on the program. Suppose you have some program, it will simply split the data based on program. In second step, suppose this program, if it is too big, if it is a too big, if it is a big, then what happened? Then it will split by sentence. Program in the sense paragraph. Suppose first it will, whatever the pages you will provide, suppose it is a very, very big paragraph. Then if it is a too big, then that split will happen by sentence. Still it is too big. Okay. Still in second phase also, it looks like it is a too very, very big sentence also. Then it is split by word. But in real time scenario, we will not use this recursive chunking, to be honest, because it is very slow down. So split by word, it means if you see in the first scenario, it will check how much paragraph is there. If it is a too big, then in the second step, it will split on the basis of sentence. Still, if it is a too big, it feels that it is too big, then sentence will be again splitted it on the basis of words. Okay, it means this splitting is happens on what? Iteration, iteratively. Okay, it is not like that, like in above methods, if you see in fixed size or some other methods, it is only one time chunking is happening. But here it is a number of times. It is happening number of times. And that's why we are saying this. It is a recursive chunking. Understood now? What is meant by recursive chunking? Everyone? Guys? Everyone getting? So what are the 5 types? So first we will take, okay, we will take one more time. So first is fixed size chunks. Second is paragraph based chunks. Third is semantic chunking. Fourth is token based chunking. And last one is a recursive chunking. In recursive chunking, the chunking will happens iteratively in loops. Okay? Understood now? Everyone? Clear? Any doubt? Guys? Any doubt? So this is all about the chunking methods. Okay? So please fill the form. If you have any doubt, please let me know. Okay? So this is the RAG. And in RAG and fine tuning, comparison, if you say in most of the interviews, they will ask you what is a RAG, what is a fine tuning, how we can do the fine tuning, how we can do the RAG, how we can real time do this. So that we will see. Okay, I will tomorrow I'm going to show you real time RAG project, but that is very we can say we will see some introductory, but yes, how we can do the RAG implementation. And also tomorrow we will try to cover some this deep learning concepts. Okay, how the neuron will work, why we'll require the neurons, how the neural network will work. So this all the things we are going to cover it in depth. Okay, everyone getting? Yeah. Please fill the attendance form. If you have any doubt, please let me know. Otherwise, we will. Please fill your review session link, guys, and fill the attendance form. By the way, our new batches is going to start from the Monday. So Monday we have next Monday from means 11th of the May. We are going to start our new batch. Please start enroll for our regular session. Now you will get a idea. And to be honest, in regular sessions, we will take a more practice with you. So it will be hands-on, automatically happens. Okay? Yeah. Please fill your attendance form and review link. Today we will going to wrap early because I have some urgent stuff. So I need to complete it. Sorry for that. Tomorrow we will connect on time, 7:30. Any security point in the RAG when we access from? Yes, definitely. We have, because without API key and everything, API key is nothing but what? Security only. Yes. Yeah. So please fill your attendance form and review link. And if you have any doubt, please ask. Otherwise, we can wrap up the session. Thank you very much. Please fill form and connect with our admin team for the admission process. Okay. Thank you very much. Bye.